In this problem, we want to find the eigenvalues and eigenvectors of a 3x3 matrix. There are matrix here, minus 3, 10, minus 5, 0, minus 2, minus 3, 0, 5, 6. I want to find the eigenvalues and eigenvectors. So we start by finding the eigenvalues, and we do that by looking at the matrix A minus lambda I and taking its determinant. So in this case, A minus lambda I means subtract lambda off the diagonal of the matrix, so minus 3 minus lambda, 10 minus 5, 0, minus 2 minus lambda, minus 3, 0, 5, 6 minus lambda. Now I want to find this determinant. And to do so, we want to pick the right row or column to expand along. And here, we want to expand down column 1 because there's only one non-zero thing in column 1, that minus 3 minus lambda. We know then that the determinant of A minus lambda I is going to be what? Well, it's going to be minus 3 minus lambda times negative 1 squared, or positive 1, times the determinant of the bottom 2 by 2. We compute that determinant. So I get a minus 3 minus lambda times minus 2 minus lambda times 6 minus lambda plus 15. We can expand out that polynomial on the inside. We're going to minus 4 lambda from the 6 is negative lambda, and then minus 2 times minus lambda gets me negative 4. So this then becomes minus 3 minus lambda times lambda squared minus 4 lambda plus 3. And this we know factors as lambda minus 3, lambda minus 1. So this polynomial is going to equal negative lambda plus 3, lambda minus 3, lambda minus 1, which means my eigenvalues are 1, 3, and negative 3. Great. Now for each of those, we want to find a corresponding eigenvector. So we'll start with 1. And in that case, the matrix A minus I is what? We'll take the original matrix and subtract 1 off of the diagonal elements. Now we want to row reduce this matrix to figure out what vector here is an eigenvector, or what values v1, v2, v3 can I put into this to give me an answer of zeros with not all the v's being 0. The thing I see right off the bat is I can divide the second row by minus 3 and the last row by 5 and see where that gets me. So if I do that, I will get that this reduces to minus 4, 10, minus 5, 0, 1, 1, 0, 1, 1, which is great, because now I can cancel out those two rows. I can start working with this from here. I could have had the first row by minus 4, but I really don't need to figure out what's going on here. So this equation here tells me that v2 plus v3 equals 0, or v2 is negative v3. So putting that into the first equation gives me negative 4v1 plus 10v2 minus 5v3 equals 0. But if v2 is negative v3, this becomes negative 4v1 plus 15v2 equals 0, because the 5v3 is now negative 5v2, so they add together to give me 15. And I want to pick values to make this work. So the easiest way to do that is just by looking at swapping the coefficients. So I can solve this with v1 equals 15 and v2 equals 4. I will then get 60 minus 60 is 0. And if I have that paired with this equation up here, this means that v3 is going to be negative 4. So conclusion here, for lambda equals 1, an eigenvector is v1 equals 15, 4, minus 4. There is part 1 of 3. Now we continue. For lambda equals 3, I want to subtract 3 from the diagonal of this matrix. So A minus 3i is going to be this matrix here. And we see a very similar pattern happening, with the case that row 2 and row 3 are the same to minus signs. So I can cancel them out. And I can now look to plug in numbers to make this work. Again, I don't need to find the exact solution. I know I'm going to get multiples of some vector. And so I can just find any numbers that work as long as they're not all 0, and that'll get me a valid answer here. So equation 2 tells me that minus 5v2 minus 3v3 equals 0. or making them positive, 5v2 plus 3v3 equals 0. I can do this by picking v2 equals 3 and v3 equals minus 5. 15 minus 15 is 0, we're good. I can then take those two numbers and put them into the first equation to see what v1 has to be. So minus 6v1 plus 10v2 minus 5v3 equals 0. This becomes negative 6v1 plus 10 times 3 minus 5 times negative 5 equals 0. So negative 6v1 plus 30 plus 25 equals 0. 6v1 equals 55. v1 equals 55 over 6. There's v1, v2, and v3. Conclusion here. For lambda equals 3, an eigenvector is 55 over 6, 3 and minus 5, or you could scale this up by 6 and get 55, 18, and minus 30. Either of those work as an eigenvector in this case. And finally, for our last eigenvalue, if lambda equals minus 3, so I add 3 to the diagonal entries, getting me this matrix here. Well, that first column of zeros is something. And I can row reduce from here. I can swap row 2 with row 1 and then cancel down. And what we'll see from that, 0, 0, 1, minus 3, 10, minus 5, 5, 9, 0, 0, 0. And no matter what I do here, I will wind up with something that looks like 0, 1, minus 3, 0, 0, 1, 0, 0, 0. I can divide that row by 25 and then cancel the one below it. All that stuff works out fine here. And so what that tells me is that v3 equals 0, and then v2 minus 3v3 is 0, so v2 is also 0. v1 I have had no constraints on the whole time, so v1 can be anything, so I can make it to be 1. And so what I get then for an eigenvector here is 1, 0, 0. There are your 3 eigenvalues and 3 eigenvectors here. For negative 3, it's 1, 0, 0. For 3, it's 55, 18, minus 30, or a scaled version of that. And for 1, it was 15, 4, and minus 4. That's how you go through this problem of looking at a matrix, finding its eigenvalues, and going on to find the corresponding eigenvectors by row reducing and by solving these equations you need to find these different quantities.